Okay, so hi everyone, my name is Ayush, and today we are going to discuss the classic cookie challenge problem, which was given by Hitesh Choudary in the first Saturday coding challenge. So let's get started. Let me first explain the problem. So basically, we are given a 2D matrix, something like this, and this matrix is the representation of a cookie, a chocolate chip cookie, and it is populated with two values only, zeros and ones. If wherever there is a one, basically the element which represent one is the chocolate chip that is inside a cookie, and the zero element or zero, basically wherever you see zero, that is cookie dough. Okay, so this is basically the representation, and the task given to us is that we have to find all the chocolate chip sequences and their respective lengths. So what do we mean by that? All right, so let me explain what do we mean by chocolate chip sequence. So basically, wherever you see a horizontal or a vertical number of ones in the matrix, and they have to be consecutive. They can be a combination of horizontal and vertical, but they need to be consecutive. So that is basically sequence, chocolate chip sequence. So let me show you. One we can already see. I've been highlighting it. So we have it right here. This one is a choco chip sequence. Another one right over here. Then we have one over here. This one is a valid sequence. It has length 1. Then another one over here, and this one here is also a sequence. This is a combination of horizontal and vertical sequence. So this is also valid. It is of length 5. So in this particular matrix we have 1 2 3 4 and 5 consecutive sequences, chocolate chip sequences. Okay, so this was the basically description of problem. Here we have a constraint that we cannot reuse or divide a sequence that we found. For example, we have found this sequence, this very long sequence, and what a possible thing could be is that we can go ahead and divide it into part of 2 or a single sequence, but this is not valid, so it will be incorrect, and we can't do that. So that is basically the description of task. Alright, so now let's discuss how we are going to solve this problem. This is basically my approach, how I approach to solve this problem. So I'm using a breadth first search algorithm. This is a very popular graph traversal algorithm, and if you don't know, I'll give a detailed descriptive video. I'll link it below in the description, and you can go watch it. It is a very good video, and you'll get totally understand the concept of breadth first search. In brief, basically what happens in this algorithm, we have a graph and we start with the node. Here they have taken the starting node as 1. Then we search all the nodes connected to this starting node. So these 3 were connected, and once we find out which node is all the nodes, we are going to push it into a queue, and then the node that we selected the first, we will pop it out, and the node that we pushed, we are going to make it the root node, which was previously this node, the node with value 1, and process it similar in a similar fashion, the way this node will do all the same things that we did to this node. So this is how basically roughly how BFS works. If you want a detailed understanding, I have linked the video in the I have linked in the description. Check it out. You'll totally understand the BFS algorithm. So in order to solve this problem, what we are going to do is we will traverse this matrix in row major fashion. So basically this row first, after that we'll go through this row, we'll check each element of every row, and we'll go through each row first. You can also traverse it in column major fashion, it doesn't really matter, but I'll be doing it in row major fashion. Okay, and every time we encounter a value 1, we are going to call a function. So what this function exactly will do, I'll explain it to you step by step. So for example, when we start the traversal, the very first element we find is 1. So we'll apply this function to this value, this location basically. So what we'll do, the first thing we'll do is we'll add the location of this element to the queue. To add the location of this element to the queue, so the position of this element is 0 comma 0 in the matrix, 0 0. All right, so we have added this to the queue. Then we'll have a variable length. We are going to initially it will be equal to 0, but we will increment it by 1. Okay, this is plus equal to so the length variable will increment it by 1. Okay, then what we are going to do is we are going to check all the adjacent sides of this element that is at the position 0 comma 0. This element we are going to check all the adjacent sides, so top, bottom element, the one, the left, the element to the right. Now if it is out of bounds, we will not check it, we'll put a condition so that it does not throw an exception. Okay, so the element to the top, it will check it. If it's 1, will push its location to the queue. So the element to the top, it's not 1, element to the left is not 1, the element to the right is not 1, the element to the bottom is 1. So we are going to add this element to the queue, its location to the queue. Okay, so this will be 1 comma 0. Okay, this element's location we have added to the queue. Now we are going to pop this element, which is we are going to remove this element's location from the queue. Okay, so we'll remove this element from the queue, and the final step, we are going to change the value of this element. We'll set it to -1. Okay, you can select any value instead of -1, but it should be unique, it should not be 0 or 1, or maybe you can set it 0, but -1 will be like more specific. You can choose any value, it doesn't matter. I'm going to choose -1. So this value is now -1. Now we are going to call the same we are going to repeat the steps we followed in we applied on this element. We are going to apply this all these steps to the we are going to that we push to the queue. So basically we are going to apply all these steps to this element. So first we already have it over here. Okay, we'll increment it, so length will be equal to 2. Then we'll check the element to the top to the left, to the right, to the bottom, and you can see none of these are 1. We have changed this value to -1. So basically where we don't have any more value to add into the queue. Okay, so we'll pop this value and we are going to change it to -1. Okay, so this is basically what we are going to do every time we find a value which is equal to 1. And in this, okay, so now I'm going to give you another example. I'll explain you with one more example. Okay, so let's take this one. Suppose after traversing a while we reach this element. Okay, first thing we will store the location of this element in the queue. So this is 1 comma 0 1 2. Okay, this will be stored 1 comma 2 in this queue. Okay, now we will also increase the length of the sequence. Okay, it doesn't really matter if you do it later or before, we just have to do it. So left. Okay, we'll check each side and we will only find it in the bottom. We find value 1 in this direction in the bottom element. Okay, so we'll store its location in the queue. So that will be 2 comma 2. Okay, we've added it to the queue. Then we will set the value of this element equal to -1. All right, now this value is this value right here is -1, and we'll apply the we'll also remove that element from the queue. So this element over here will be removed. Okay, so this one is removed. Now we'll apply all the same operations on this element. Okay, so we'll check the top, left, right, and bottom. Okay, so the element on the top is -1. We won't be adding it to the queue. The element on the right is 0. The element on the bottom is 1. So we'll add it to the queue. Its location will be 3 comma 2. Okay, 3 comma 2. We've added it to the queue. We'll increase the length. Okay, from 1 to 2 we'll increment it by 1. Okay, then we are going to remove this element's location from the queue, and we are going to change the value of this element. We are going to set it equal to -1. Now we are going to apply the same operations to the element, this element location that we have stored over here. Okay, we'll check the top, left, bottom, and right. Okay, we'll increment the length by 1, and we're going to check all the sides. The top is -1, left and right are 0, and bottom is 1. So we'll add the location of this element, the bottom element, in the queue. I'm going to add it over, but it will be pushed to the last location, or it will be pushed to the end of the queue. Okay, I don't have space over here, that's why I'm adding here. Okay, so the location will be 4 comma 2. Okay, we are going to remove this element. Okay, and we are going to set it equal to -1. Okay, so this is -1. Now we are going to apply all the same operations to this element, the element with location 4 comma 2. So top, left, bottom, sorry, top, right, bottom, and left, and we're going to increment the length by 1. So the length will be equal to 4. So the length will be equal to 4. Now we'll check all the directions. So top is -1, left and bottom are actually left is 0 and bottom will not check because it will be out of bound, and the element to the right is 1, so we'll store that location. So that will be 4 comma 3. We'll remove this element from the queue, this element's location from the queue, and we'll set this element's value equal to -1. So the value of this element is set to -1, and now we'll apply the same operations to this element, the element over location 4 comma 3. Okay, so we'll increment the okay, so we'll increment the length will be equal to 5. Okay, now we'll check the top, right, bottom, left, all the elements, none of the elements around it are equal to 1, so we won't be adding anything. We'll simply remove it from the queue. Okay, we will remove it from the queue. We've already incremented the value of length, and we'll return this length value. Okay, so that is basically the entire process. I hope you understood it, and now we are going to code it. So now the fun part begins. Let's start the coding. I'll use Python, but basically if you understand the idea, you can implement this in any language, but I'll be using Python. Okay, so I have completed the code, and this is it. So I actually didn't record coding because I don't have a mic, and it was quite tough to type and hold the phone to record the audio. But anyways, I'll explain the entire code to you. So basically, execution of this code starts from this line over here. First thing, we'll ask the user to enter the height and width of the cookie. So the dimensions of the matrix, we'll ask the user to give the dimensions of the matrix. Then what we're going to do is we will take the values values of the matrix. So for that we are going to traverse through loops. Okay, and I'm using a while loop here just to check if the user has entered the input and if the user has entered the input correctly or not. So if the user basically suppose the length of row is 5 and user enters a row with elements 3 or maybe 7, then it would be wrong. So to check, just to check that, I have added I'm using a while loop, and I used some extra if checks. Okay, so that is that. And here in this block, in this entire block, I'm just entering I'm just taking the user input. Okay, then length of all the cookie sequences that we find. Okay, and in this block, this is the block where the actual process starts. So we are traversing the two-dimensional array using two for loops, one for the what do you call one for the row and one for the column. Okay, and if while traversing we find the value equal to be 1, so we are going to call the bfs function. Okay, and the value returned from bfs function will be appended to this array. Okay, so bfs function will return the length of the sequence that you find, and it will append it to this array. So let's it takes 5 parameters. The first parameter are the dimensions of the matrix m and n, and the I and j are the location of the current element, or the element to which we want to apply the bfs function. So these are the 5 parameters that this function takes. Now let's get to the function. So here's the definition of the function. The first thing we do here, I have taken the name of the queue is to check. Okay, so while explaining, I told you that we're going to use a queue, and I named it to check. Okay, so to check is just a variable and it is a list, but I'm going to use it as a queue. Okay, then I am setting the length is equal to 0 initially, and the initially the value of the location of the element that we are applied that on which we applied this function. Okay, so it has the location of I and j. Now we'll run a loop until the queue is not empty. So once the queue is empty, we'll stop executing this loop. This while loop will stop its execution once the queue is empty. Until then, we'll keep looping it. So the first thing I'm doing here is I'm adding incrementing the length by 1. Then I'm checking. This check is another function. So what it basically is doing is it is checking all the adjacent sides of that element, and basically checking that if we have a 1 in adjacent sides or not. And if we have it, we will append it to the queue, this to check queue, and set the value of the current element that we're checking equal to -1. So here is that function. Okay, okay, so right here we have the check function. So what we are doing exactly in this function is that first off we are taking the coordinates of the element that we are checking. So that is I and j. We are taking the coordinates. Then we are checking the element on the top. So these conditions are basically to check if if whether the element is out of bounds or not. If it is out of bound, then we won't be the condition will be false and we won't be accessing the element. And if it is true, then we are going to append the location to the queue, that is the to check queue. Okay, so these are the four directions basically. First we check on the top, then to the left, then to the right, and then to the bottom. Okay, once we checked and we find that we have element on one of our adjacent sides, so we'll append it. And once we have done that, what we are going to do is set the current element to -1. As I explained, we are going to check all the directions and add the if we find an element with -1 value 1, we are going to add it to if we are going to add its location to the queue, and we are going to set the current element equal to -1. Okay, Then after executing this to check function, oh sorry, the check function, we are going to pop the first element from the to check queue. Okay, because we have already checked it and we have found all the adjacent elements, so we are going to remove it. Once after executing this step, if we have more element in the queue, so we are going to loop again and again repeat all these steps. And if we do not have any other element in this queue, we are going to return the length. We are going to return the length of the sequence that we found out in this entire function. So this length will be returned over exactly here, returned here, and it will be appended to this lengths array. It will be returned to the lengths array. It will be returned to the lengths array, and we will print the length. So this is the code, and I'll link if the code is not visible exactly, I'll provide a link to this code in the description. So thank you guys for watching. If you liked it, hit the like button, and add a comment if you want, and subscription is not compulsory. If you want, you can subscribe, but I guess you should subscribe to Hitesh Choudhary's channel. It's a great channel, it has great content. So yeah, thank you all.